Hello and welcome to your lecture on Learning Outcomes 18 and 19. In this lecture, your objectives are to calculate the actual dimensions from scale drawings and create a scale diagram given actual measurements. You also need to be able to use coordinates in 2D positive and negative grids to specify the position of points. So, in this lesson then, we're going to start with coordinates just so that you understand how to do them and how to plot them, and then we'll move on to scale drawings. Okay, so first of all then, what I'd like you to do is pause the video and have a go at writing out as many of these coordinates as you can. So if you want to label them a certain way, you can do, but try and think about how many of these you can label, and then I'll put the answers on. Okay, if you've paused the video and had a go at that, here are the answers. Now, I know some of them, they're like a little bit, they're not perfectly placed, but I'm sure you've got the majority of them correct. Now, we need to make sure that we understand the axes here. So, I'm just going to explain a little bit about coordinates. If we look at this coordinate just here, -4, 3, okay, we have to say the x-coordinate first, and x is always the first coordinate, okay? So this is our x-axis, and this is our y-axis. So that means that 3 is the y-coordinate, and that's the same for every single coordinate on here, okay? X is always first, y is always second. This will help you later on in the lesson, okay? X, Y, X, Y. I'm going to label them all because I want to. All right, so X, Y. Okay, so let's just start labeling a few points then. So first of all, let's label this point up here, okay? This one. Now, what you need to do is you need to remember that we have to go across the landing. I'm going to write this here. Across the landing to write down your x-coordinate, and then up or down the stairs to write your y-coordinate, okay? So we start at 0, 0. I know there's a point going through that, but that's fine. We start at 0, 0, and we go through all the way to the line where the point is sitting, okay? This point is sitting at 3, all right, because if we go up to the point, it's actually on 3. So our x-coordinate is 3. And then if we go up the stairs, we can see that it's sitting on 4 on the y-axis. Okay, so our x-coordinate is 3, our y-coordinate is 4. And you'll notice that everything in this quadrant has got a positive. Everything is positive in this quadrant, okay? Because we only have positive x values and positive y values going up there. All right. Okay, let's label this point down here. Okay. We're going to go across the landing. It's sitting on -2, so -2. And then down the stairs this time. So if we're going down the stairs, you can see that it sits on -2. Okay, so x is -2 and y is -2. You will also notice that everything in this quadrant is negative, because we have all negative x coordinates and all negative y coordinates. Okay? Right, let's just label a couple more then. So why don't we label this one just here? Okay. Again, across the landing, so we start at 0, 0, across to -2, and up. So across to -2, that means our x-coordinate is -2, and up the stairs, which means y is sitting on, all the way up there. Y is sitting at 2. So x is -2, y is 2. Now you will notice that in this quadrant, we have positive y coordinates, but we have negative x coordinates, okay? And that's because you're going up the y-axis, but you're actually going backwards into the x-axis, so you have negative x coordinates. You don't really have to remember these, I'm just explaining it so that when you come to plotting coordinates you find it easier. Alright, finally let's plot this coordinate down here. So again we go across the landing till we get to the point, and the point is sitting on 3, and then down, and we can see that it's sitting at -2. So x is 3, y is -2. And again, you will notice that this one's the opposite of the other one, and you will have a negative y axis, negative y coordinate, and a positive x axis, x coordinate, sorry. Okay, so you just need to remember the rule. We go across the landing and write down the x coordinate, and then we go up or down the stairs to write down the y coordinate. It's very important that you remember that this is always x, this is always y. Try not to write them the wrong way round. Okay, people lose valuable marks by just writing things the wrong way round. So now that you know how to do that, let's look at some scale drawings. Now, what are scale drawings? Scale drawings can be used for loads of things, and one of the main things you're going to have to use scale drawings for are maps. Okay, so maps or blueprints of houses. So they're the main types of scale drawings you're going to look at in functional skills and what you would get in your exam. However, scale drawings can also be used for vehicle design, as well as, you know, this one here of different types of fish. So they could be used for a lot of different things. Now then, a scale drawing allows us to draw large objects on a smaller scale while keeping them accurate. All scale drawings must have a scale written on them. Scales are usually expressed as ratios. For example, 1 centimetre is the same as 100 centimetres. Usually they would write it as 1 to 100. And then you would look at the diagram, and if something is in centimetres, you can then decide that it means 1 to 100, like that. Unless you're told otherwise, which you might be. So the ratio 1 to 100, or 1 centimetre to 100 centimetres, means that for every 1 centimetre on the scale drawing, the length will be 100 centimetres in real life. Okay, so you must remember that that's what that means. This first value is on the scale drawing, and this second value is real life. Now then, you'll see what I mean in a second when I go through some examples. You might also be given one a bit like this. 1 centimetre equals 2 metres. This means that for every 1 centimetre measured on the drawing, it's 2 metres in real life. So it might not always be 1 to 100, and it might not always be centimetres to centimetres. It might be centimetres to metres like this one. So let's see why we need to know these. Okay, so the first question here doesn't actually talk about scale drawing necessarily, but I thought it was quite a good one to put in. The first question says, which place is exactly northeast of the park? So you've been given a map and you've been given a scale. You don't need the scale for this first question, you'll need it for the next one. Okay, but I just wanted to ask this question. Your map has got a theatre, a station, a bank, a park, a mall, and a police station. And your question is saying, which place is exactly northeast of the park? Now, the reason I wanted to put this one in is because we just need to make sure that we are aware that we have 4 sides to a compass. The top being north, this one being east, this one being south, and this one being west. In between each of those, we also have other measurements. In between north and east, we have northeast. In between east and south, we have southeast. In between south and west, we have southwest. And in between west and north, we have northwest. Okay? This question is asking which place is exactly northeast of the park. Now, northeast is in this direction up here. Okay? So here's the park. Okay? And if we drew a little 4-sided cross in there and then put in our other diagonal shapes, we can see that this is northeast, and we can see that the station is exactly northeast of the park. Okay, I just wanted to put that one in because sometimes they come up and I wanted to make sure you knew how to answer it. But that's as difficult as it's going to get for functional skills. Now then, looking back at our diagram, I don't want you to answer this question, so don't worry about this. But this second question here, this part C, says what is the distance in meters from the mall to the station? Okay, so what we need to do is we need to work out, first of all, where we go from the mall to the station. So I'm going to draw a line from the mall to the station. And it says, what is the distance in meters? Now, this is our scale, so we have to use this. And what we're going to do is we're going to measure our line. And our line says that it's 8 centimetres. If our line is saying it's 8 centimetres, we can look back at our scale and it's telling us that 1 centimetre represents 200 metres. That means for every 1 centimetre on the drawing, there are 200 metres in real life. Well, we've got 8 centimetres here, so we need to do 8 times 200. And 8 times 200 is 1600 metres. So our answer is 1600 metres, or 1600 metres. Okay, so that's a very common question that you would get in the test. Now, let's have a look at another type of question. This question says, here is a map of an island with cities A, B and C. The straight lines represent roads. Okay, so from A to C, that's a road. From C to B, that's a road. And from A to B, that's a road. Okay, or from B to A, whichever way you want to look at it. So they're all roads and they all join together like that. It says that Joe drives from A to B on the route shown. Ash drives from A to C to B on the route shown. Use the map to work out how much further Ash drives than Joe. You must show your working. Okay, so there was a question for this part here. Don't worry about that. Alright, that's not a question that I want you to answer. What I do want you to answer is this section here, and it's worth 5 marks. So it's quite a substantial amount. So if you want to pause the video and have a go, you can do, but you might find it a bit tricky because with questions like this, you will have to measure the lines. So in your exam, you will need a ruler. So I'm just going to go through it. And what I thought I would do first is I would take my ruler and I'm going to measure all the sides. Okay, just because I know I'm going to need them all, so I'm going to measure them all. Okay, you don't have to do it this way. You could use the question and just measure what you need, but you are going to need all of them. So I'm going to measure A to C. And A to C measures 4 centimetres. And then I'm going to measure C to B, and that measures 3 centimetres. And then I'm going to measure A to B that way, and that measures 6 centimetres. Okay. So now I know what they all are in centimetres, and I've got them written down here. I'm then going to use my scale to work out what they are in kilometres, because every 1 centimetre represents 200 kilometres. So, first of all, I need to do 4 times 200 because A to C measured 4 centimetres. So 4 times 200, or 4 lots of 200 kilometres, is 800 kilometres. Then I can do 3 times 200 because C to B was 3 centimetres. And 3 lots of 200 kilometres is 600 kilometres. And then finally, I can do 6 times 200 because B to A, or A to B, measured 6 centimetres. And 6 times 200 kilometres is 1,200 kilometres. Okay, so now I know all of that information. And now what I'm going to do is I'm going to work out the distances that both Joe and Ash travelled. So I'm going to start with Joe. Joe travelled 1,200 kilometres in total, because I know that Joe travelled from A to B, and I know that A to B measured 1,200 kilometres. Okay? So I've written that down. I'm then going to work out what Ash travelled. And Ash travelled from A to C, which was 800 kilometres, and then from C to B, which was 600 kilometres. So if I add them together, Ash travelled 1,400 kilometres. It says use the map to work out how much further Ash drives than Joe. So we just need to do 1,400 take away 1,200, and we can see that the distance was 200 kilometres further. So our final answer will be 200 kilometres. just like that. Okay, so hopefully that's not too difficult for you. We tend to just multiply the amount of centimetres by this number here. Okay, but sometimes it might be a little bit trickier than that, but that's the general concept. Now then, we might also be asked to work out different measurements based on different types of scale drawing. So for example, here's a drawing of a TV, and the scale of this drawing is 1 centimetre to 25 centimetres. What is the actual width and height of the TV? So you could work this one out without a ruler. You don't need a ruler for this one. You could have a go at this. If you want to pause the video and do that, then go ahead. Okay, if you've had a go at that then. First of all, this one's 4 centimetres long, and for 4 centimetres on the drawing, it represents 25 centimetres in real life. So 4 lots of 25 is 100 centimetres. And then this one is 2 lots of 25, which is 50 centimetres. Okay? Not too shabby. Now then, another thing that you might be asked to do is draw an actual scale drawing. Okay, so that's what we're going to do next. So for example, this question says, using a scale of 1 centimetre equals 9 metres, pause the video and try drawing this accurate version of this triangle. Okay, so what you've got to do there is think about, how can I draw that triangle using this scale? Okay, if you've paused the video and had a go, it's telling me here that this is the real life triangle. Okay, I know that because it's telling me all the measurements in really high numbers. I know it's not the real life triangle because it's smaller, but what you need to do is you need to think, well, if 1 centimetre represents 9 metres, what would this side be in centimetres on a drawing? So for each side you would just divide by 9. 27 divided by 9 is 3. 45 divided by 9 is 5. And 36 divided by 9 is 4. You can then take your ruler and you can do an actual scale drawing using actual centimetres of the triangle. Okay, so that's sometimes something that they would want you to do. Now, another example is doing the scale drawing of things inside a house. So that's what we're going to look at next. Now, this type of question is a little bit more difficult, but you're given some information and you need to put it onto a scale drawing. So sometimes they'll give it you like this, or sometimes it'll be like a square grid and you've got to fit like a greenhouse on it or something like that. So this question says, Molly has a plan of her kitchen and wants to fit all of her units into it using her plan. Use the measurements to draw a kitchen plan where 1 centimetre on the plan is 10 centimetres in real life. Use the plan sheet provided. Take care not to put the cupboards in front of the window. Okay, so it says something a bit like that, and then it will give you some information. Kitchen, 200 centimetres wide and 300 centimetres long. Okay, that's fine. You are going to have 2 cupboards, which are each 60 wide and 80 long. Then you've got 2 units, which are 60 wide and 60 long. Your sink is 60 by 80, your washing machine is 60 by 60, and your cooker is 60 by 60, and so is your fridge. Okay, I'm not sure where I got this question from. The measurements seem a little bit off in terms of an actual kitchen. I think, obviously they're not going to be, they're not going to show you the height. They're just going to be showing you the width and the length, because it's a plan, meaning you're looking down on it. Okay. So there might be some differences in the questions you get, but in any case, this is how you would do it. So you've been told that your scale is 1 centimetre to 10 centimetres. Okay. So we know that we have our kitchen here, our measurements for our kitchen, so we don't really need to do anything with that. What we need to do is work out how many centimetres are going to go on the plan if we've got these in real life. Okay, so 60 wide and 80 long, or 80 long, I suppose. Okay, so you're going to say, if I had a kitchen cupboard and this was 60 and this was 80, because of my scale, I need to divide each of these by 10 that would give me 6 centimetres, and that would give me 8 centimetres. So on the plan, I can draw a 6 by 8 centimetre rectangle, and it would be in perfect place. Now, I would advise you to sketch these in very lightly, because you might have to move things around, and you need to make sure you don't put anything here. All right. Now, because you've done that, we then can see that these units here are going to be 6 by 6. This one's going to be 6 by 8. This one's going to be 6 by 6. So is this one, and so is this one. Okay. Sometimes a question might tell you that they want a certain amount of space around something, and you've got to work out how many centimetres that would be and make sure you leave that much of a gap. All right. But in this case, we can just add in our cupboards now. So I've got my 60 by 60 centimetre ones here, my 60 by 80 centimetre ones here, my sink over here, my washing machine here, okay, and my cooker in there, and then my fridge. Nothing is in front of the window, and nothing is blocking the door. And you've put in all of the units in your kitchen. The washing machine may have gone there, depending on, which way around the cupboard's open. Okay? All right, so I hope that was useful. Let's have a look at a different type of question then now. Okay, so this question is asking you about this map of the Olympic Village. The questions that you've got here says, how far is the Olympic Stadium from the Aquatic Centre? And how far do you have to walk from Stratford International Station to the Copper Box for the handball event? Sorry, I probably should have put the L there rather than there. I think it's the way the text box has been done. Okay. Now, when you've got something like this, what you need to do is you need to look at the scale given to you down here. Okay, and you would have to measure that using your ruler. Okay, so it's saying how far is the Olympic Stadium from the Aquatic Centre? So I would put a dot where the Olympic Stadium is, and I would put a dot where the Aquatic Centre is, and I would draw a line. Now, you using your ruler, if you got this on a paper test, would measure this, and you'd work out how many of those fit in there. Okay, so I've taken it like a bit like this, and I've put 1, 2. Okay, maybe not quite accurate there because I've got a little bit of a gap, but I've probably gone over the dot a little bit as well. That's 2. 2 of these, which each of them measures 200 metres, if you can see that. Okay, so that means that it's 400 metres. Okay, again, you'd probably measure it a bit more accurately than I have. How far do you have to walk from Stratford International Station, which is there, to the Copper Box for the handball event, which is there? We'll draw a line and we'll see how many of those fit in there. Now, when I did this, 4 fit absolutely perfectly, so I don't know what's gone wrong with my presentation here, but I know that it was 4. I did fit properly 4 of these in, okay? So trust me, it was 4. But like I say, you will measure it using your ruler anyway and be a bit more accurate. So I've got 4 of these, okay? And that's 4 lots of 200 metres, which is 800 metres. So that would be the answer to that one. So when you're using scale, all you're doing is, for this type of question anyway, you've just got to use the scale that they give you and work out the distance in real life based on how many centimetres you have. So this could have measured about 1 and a bit centimetres on your ruler, in which case you would have said, okay, well, I've got like 4 of those, so it's 4 lots of 200. You still would have got the right answer. Okay, so another question then. This is Mercury. Mercury has a diameter of 5,000 kilometres. Okay, the scale is 1 centimetre to 1,000 kilometres. Can we draw Mercury as a scale drawing? Okay, so basically what I'm saying is, if Mercury is huge and it's like fits the entire, obviously it won't fit the entire page, it'd be massive. Okay, so Mercury has a diameter of 5,000 kilometres. How would we work out how that would be drawn on a piece of paper? So what we would do is, if we've got 1 centimetre is 1,000 kilometres, what we can say is that 5,000 kilometres is 5 centimetres then. Can't we? Because we would have had to times by 5 to get to 5 centimetres. So we'd have times by 5 this side to give us 5,000 kilometres. And if I was to draw this then now, I would draw a 5 centimetre long line, which would go about to there. Okay. And then what you would have to do is you would have to use a compass, okay, which is one of those things that draws a circle, an accurate circle. And if you had a compass, not like me, because I'm doing it on the computer, it would look something a little bit like this. All right, what you would do is actually you would put your compass right in the middle, and you would put your pencil on the edge there, okay, and it would draw, well actually you'd put it there because then you can measure how wide it is, and you would draw a circle going all the way around, and it would give you a nice accurate circle, okay. So let me just show you that one more time. So you would draw your line, okay, you would draw your 5 centimetre line because that's the diameter, that's the middle, and you would then put your point of your compass in the centre, and you would put your pencil on the edge of the line, and then you would nicely, I mean again I'm not going to do this properly, make a circle. You would nicely make a circle. It would be an accurate circle as well, not like mine. Okay? Okay then, brilliant. Okay, so I hope you feel better now about calculating actual dimensions from scale drawings and creating scale diagrams given actual measurements, and I hope you feel confident plotting coordinates in positive and negative grids. Alright? So I look forward to seeing how you do on this assignment, and I'll see you in the next video.